Hi and welcome. In this project I'm going to be trying a very basic attempt at making some V-blocks that are a little more useful than the standard 45-degree V-blocks. These kind of V-blocks are great for holding small diameter parts to give you 3 points of contact, because without a V-block you're looking at 2 points of contact, the opposite sides of a diameter of a circle. And as a result, it's not a particularly stable way to hold a part. But if you were to put a V-block in place, press up against it, now it's rock solid. Notice there's 3 points of contact, one here, and one here. That's a great advantage. So what do you do when you want to work on a part with a diameter like this? Well, the answer is you can use a V-block, but these V-blocks, not only is the angle so sharp that if I had a V-block large enough to hold this and touch just on the sides, 45-degree angle, it wouldn't fit in the vise anymore. So this one is going to push the points, the edges, into the vise and damage the part, which is no good. So the solution I want to come up with is a V-block of a gentler angle than 45, say 10 degrees, that a small V-block will still be able to hold a part this large a diameter in 3 spots. And I have a project coming up where I have to drill into the end of this guy, and I want to be able to hold it better than just tightening the vise on 2 sides. It's fairly stable, but I think we can do better. So my point is to make a gentle V-block. Now, I'm going to say a caveat up front. I know that I'm not going to be able to get extreme precision doing this on a mill, and what it really needs is the mill would be the roughing cut. Take the tool steel out I'm going to use, get it heat treated, and then follow that up with surface grinding. I don't yet own a surface grinder. It is on my long-term list of things to acquire, and once I have one, I will be able to correct these blocks so they'll be much higher precision. Anyways, let's get to it. So I thought I'd use tool steel, but the problem with tool steel is when you buy pieces like this, 1/2 inch thick, 3 inches wide maybe, it's very expensive to buy tool steel like this. And I found another solution on eBay that is a lot less expensive. And that solution is to buy cut-offs of large diameter rounds. I can get some very usable stock out of this. This is also about 1/2 inch, but this was a lot less expensive than this pre-cut ground stuff. So if you're looking for a way to save money, every once in a while these guys pop up on eBay and you can save a ton of money. I got it for like 1/3 the price per pound of normal tool steel. So I'm going to face both sides of this, get it flat and square, and then I'm going to trim off the round parts, and I'll have a nice piece of tool steel that I can use with some small cut-offs that maybe I can use for something else. So next up, I'm using my height guides to set the part height other than the ground surfaces of the jaws, which I made this last time. This is part of a set I made. This is for the wider parts, and then over here I've got jaws that reach into the inside deeper with some round inserts that'll let these parts slide all the way down. The different size height adjusters. Because there's only 1/2 inch thickness here, so there's only 1/2 inch, well, less than a 1/2 inch adjustment, probably around 1/4. Anyways, so then you take your indicator, set on each one of these guys. I've got them snug down so there's a little bit of tension, and then you set them all for 0, and you're good to go. Your part will be parallel to the face of the chuck. So next up, we've got the disc mounted, and we're just going to face it off to make both sides parallel. So I'm going to face one side, flip it 180, face the other side. Long way to go. Checking out a positive brake insert on turning the face. Much better finish than my other one.
1
This one's actually designed for aluminum, but I'm only taking a 10,000th depth of cut. So to get my inscribed square in this circle, what I did was first I drew two lines perpendicular to each other that are diameters going right through the middle. And since I turned this, I knew where the middle was. So draw two diameters that are perpendicular to each other and then connect the points together and you have a square. So now I can cut off this excess, keep it still because it'll be good 01 tool steel, and I'll have a square center section I can make parts out of. So now I've cut out the inscribed square, and I'm just going to cut this guy in half to make two pieces, and then I'm going to square it up and turn it into two pieces that are dimensioned appropriately. So we're setting up here to make a rough 10-degree riser for my magnetic vise and a magnetic chuck, and the point of it is going to be to basically turn the magnetic chuck into a sine plate very roughly. We're not looking for any particularly highly accurate angle. We're going for roughly 10 degrees. So we've cut the bottom of this flat. We have some 10-degree blocks in here. We're going to mill the top of this 10 degrees, and when that's done, then I'll be able to mount the magnetic chuck onto the mill table, and hopefully it'll be strong enough to hold these pieces with light cuts to mill them to 10 degrees. That is my goal. It's a test and maybe I'll fail, but we'll give it a shot. So we're going to be cutting until I just start to kiss this edge over here. This is at this shifted angle. This side over here is the low side, so we're going to keep milling down until we reach that. Let's try the other direction because the chips are coming at the camera here. So here's the setup. I've got a block to hold down the edge on this side. I put a stop block so that it can't slide this way because as I tighten the far side, it has a little bit of force it wants to push this direction. So this is a stop block. I initially used two pins in my T-slots here to line things up just to get it roughly centered. This side I have a clamp holding down on this side, and then I used my indicator to indicate along the side of this, although the side of this isn't square, it's like within a couple of thousandths. So I got that lined up so that it's roughly square, and now we're going to give a test shot on some test material. Alright, so let's walk this guy up and just let it touch off. So really light cut so far, okay. I don't see any movement. Note that the bottom of this part, this test part, is not square, so the parallels are not meeting up with it perfectly. Alright, so let's try 10,000ths depth of cut, see what happens. So far, so good. One problem is that as I take deeper and deeper depth of cut, I'm also going to engage more and more material on the face. So I might have to reduce how much depth of cut I do as I get wider, you know, as the cut becomes wider and wider. Alright, so let's try something similar to what I was going to do, which is right down the middle of the part. So let me adjust height so that we actually engage the cutter. So here's a pretty big cut. This might be too big. Alright, that was a really aggressive cut right there. And it worked out okay. So you can see how deep that was, and we didn't have much trouble with it. That's my test piece. It actually worked pretty well. Let me see if it moved at all. It is still flush against the rear fence, flush against the other parallels. That's good. All right, so I think this is going to work out. We're going to give it a shot. So we set up here, and the goal was going to be to work to this line. And again, it's not a critical measurement because I'm not trying to make sure that this is dead center between the two sides. Just rough. Just trying to make a approximate 10-degree bevel so that I just want them to be symmetrical. So what I'll do is I'll do one half, and then I will flip the part around and do the other half. Come back the other way. So I found my X measurement, and I have set my 0, so when I flip the part around, I'll be sure to leave these two guys alone and move these two out of the way so I can put the part back in. That's my goal anyways. They're not clamped well, but they're held in pretty strongly by the magnets even when it's off. So hopefully that'll be a good solution. Okay, fail. Part moved. Have to find another solution. So it's interesting that this cutter, which is a carbide cutter as well, but it's not a face mill, applies so much more force to this guy than an insert-based cutter, which has a lot more inserts. The one I had 6 inserts, so I'm really surprised. I just tried again a second time with a 10,000th depth of cut, and it caused the same problem. So the magnet solution is not going to work for this. We're going to have to go back and start all over again and go back to the Vise perhaps. I just thought this would be an interesting approach. So it's a fun experiment, but it has failed. As tight as these are, not tight enough, and actually you can feel it's definitely not enough. So anyways, I had better luck with my test than I do with the final production version, so we are going to shoot a different way. You know, first you don't succeed, right? People wondering how to deal with parts that get magnetized like this. It's called a degaussing coil. Used to use them on TV sets to degauss the screen because there was a shadow mask in front that would catch electrons that weren't lined up very well with the phosphor or the specific pixels. So you degauss TVs all the time. Basically puts 60 cycle AC through it, which reverses the magnetic field, and as you can see, the parts jumping. And so it's pretty easy to degauss things, so not a big deal. They're not a particularly expensive item either. So this is a much more boring setup, but basically it's just clamped in the vise. We're going to take a 25 thousandths pass, and I'm using some angle plates on there, but it's not as interesting as the other solution was if it had worked, but since it didn't work, maybe that doesn't really count as interesting, I don't know. But in any case, it didn't work, so we're on to this solution. So now we flip the part over and we're going to do the other side next. And I did a high-speed, high RPM finishing pass. I might see how it performs high RPM going forward. Let's just check it out. So this next guy is the orientation is rotate. All right, so I made a really light pass to set my X0. So now we're going to take a 25 thousandths pass, and they're going to get progressively bigger and bigger, and eventually I'll have to move the X-axis so that I can hit all the material that needs to be hit. But you can see initially the area that's being cut is narrower than the width of the cutter. All right, so I didn't show this part. Here's the first half done. Now I need to just flip it around. I've added the stop before that gives the angle block a place to stop and line up. And I've got my depth set, so we'll be good to go for next time around. And we'll just do it again, really light passes until we get to the end. Here's some close-up. I'm going to be taking about 20 thousandths passes. And I'm purposely leaving the material in the middle for last. So I'm going to work my way back there a bit. I wasn't happy with the finish I was getting with the end mill, so I went to the face mill cutter, and I had already relieved the other side by cutting the angle on that one, so it wasn't going to run into it. And it's giving a much better finish, but actually the stop is higher than the workpiece, so I only put the stop bit when I'm pulling the workpiece out and putting it back in. Then I got to remove it again after I got everything clamped down, which is not ideal, but it sticks out too much, so that's kind of funny. So I'm just going to face this other side here and we'll be done. Alright, so we're just going to do some cleanup passes. We're not going to take much more than 10 thousandths off, a little bit over. So this should be pretty mild. So first pass, take about, leave 5 thousandths. we're going pretty high RPM here. And this last pass is going to be the remaining 5,000ths. Here we are. I've got the RPM at about 2,200. So we're just lining up to groove this guy, and it's not going to be a big deal. We're just going to put a groove in for chip relief down the middle. And I've already used my indicator to get center. Just 20 thousandths depth of cut. Tool steel if you care. Here's number 2. We go for about 25 thousandths depth of cut. Seems to work out all right. We're going to end up at a total of 100 thousandths. On subsequent passes, I'm not going to show you because I use a vacuum cleaner to get the chips out of the way. Because for little end mills, chip clogging is a big deal. So, here are my final parts, and they are sort of in an interim state. They're not what I would call finished for tool state, because what they really need to be is heat treated and then surface ground to get the angles and the surface finish all perfect. These are milled, and you know, milling machines only have so much accuracy, nowhere near what a surface grinder can attain. So unfortunately, this is as far as I can take them now, but what I really need was this guy. This is the one I was making this project for. This one was just because. So what this guy is useful for is, as you can see, it's wide enough to span the Kurt jaws. Here, let me put it on this side so you can see. So it's just a little bit wider than the gap in the Kurt, which is really handy. And I can deal with parts much bigger than this. This part's actually kind of small for it. As you'll see, the 2 points of contact are fairly close together here, which of course is not ideal. But what's important is that the circular surface is making contact on the flats, which it is, and that's the whole point of these. So I can do a much larger diameter part even than this with this guy here. This little guy will be handy at some point in the future if I have taller vise jaws. Then I can put it up, you know, say like here, and hold a larger diameter part horizontally, which could be very useful. I've needed it in the past and struggled to find a good work holding solution. So this is the one I needed. This is the one I made just because I had the setup. Hope you find it interesting, and thanks for watching. Hope to see you next time.